Hi, welcome to the lecture on Chapter 1. Now most of the stuff, actually all of the stuff, you'll find on the NET125 site and probably in a little bit more interactive format. But for those of you that don't like to do that, I will try to at least skim through some of the PowerPoint slides and give you a little bit of insight. But luckily this first chapter is basically just a overview of the networking field and the different things that we're going to be getting into throughout the rest of the semester. So just sit back, relax, and enjoy. Now we're going to try to look at four major areas. One is look at how wireless and networking is global. And then we're going to look at the different types of technologies that make this happen, and then kind of go down a little bit deeper and look at some of the characteristics of a network that handles the small to mid-size companies, and then look at the future trends that are happening in the industry as far as networking and business in general to coming together. So let's look at how we're globally connected. And as we know that networks today impact everything, whether we're on our phone, on our laptop, whether we're, FaceTime, somebody, it's definitely networks are bringing people closer together via technology. Now, the technology then and now, well, 20 years ago, I remember, must have been about 1994, 95. And we were building a wireless network out in LA. And my project manager came up and says, "Hey, you want to see the internet on your phone?" And I pretty much told him, "Are you nuts? Why would I want to do that?" Because back then the phone screen sizes were like a 1x1 inch, just enough to put in a phone number was about all the size were. So to be able to look at the internet on that phone just didn't make any sense. Today, I wouldn't do without it. I'm on the internet more on my phone than I am anyplace else. So the technology definitely has changed. There's no boundaries. You can take this network anywhere. Any place you want to be in communication, you're there. You can talk to anybody, anywhere. It definitely has affected how we teach classes. Well, look at this class. It's an online class. So you don't have to be in the classroom, listening to me talk to you, but you can be anywhere. You can be in your car. You can be in your laptop. You can be in your bedroom. You can be anywhere you want. And you're still getting education. You can still have it. So it's definitely supporting the way that we like to learn. But it also, from a business standpoint, it's also the way we like to work. Most businesses have a global impact. Their communication formats are emails, text, social media, collaboration tools, blogs, wikis, podcasts. That's just the way we do business. And as a culture, we're used to doing business that way. So networking allows me to work that way. So, it just means I got to make sure that I've designed a network to keep in tune or up to date as the technology changes. It also affects the way we play. Video gaming, movies, TV, music, all of that stuff is streamed live. So we are using networking in every way, shape, or form the way we're doing it. Now, I'm not assigning this lab as far as research and collaboration tools, but if you're interested, just take a search through some of the tools that are out there. How to create wiki pages, conferences and web pages, sharing documents. But networks come in a variety of sizes. Small home networks, like you see here, pretty much in your house, you got one wireless access point that covers your whole house. It could be a small business, has multiple computers, multiple people working together. It could be a small to large size business, which now you're talking about 1,000 or so, hundreds of thousands of connected computers, or it could be a worldwide. Different countries, different factories, different places. So and how I design each of those networks at those sizes makes a difference. And we'll talk about some of this. Most of the activity we're going to do in this class are going to stay to the small home networks and the small office, home office environment. Now, there are different ways that computer networks are built. One is a client-server model, where a client is basically a user at making a request for services, and the server is the one that responds to that request. So your email server, for example, you send an email, hit return, that message goes someplace, and you don't have to stay logged in to stay connected to it just to make sure you're going to get that email back. It's going to go to some centralized repository and wait for you to read it at your convenience. There's also a peer-to-peer. Now, peer-to-peer is when you got two computers directly connected. Real small businesses and homes might work, but they're easy to set up. They're not very complex. They're pretty inexpensive. But also, if in the picture I've got here is like, okay, what happens to the PC that says I'm print sharing is turned off? Do I have access to the printer? The answer is no. So a peer-to-peer network, easy set up, but does have some drawbacks. Now let's get into a little bit more on LANs and wide area networks, and the internet. Talk a little bit about some of those. Now, there's three different types of equipment that we're going to deal with. Basically, a network can be as simple as a single cable connecting two computers, or it could be a network connecting the entire world. And network infrastructures usually contain three different types of components. There are physical devices, your PC, your phone. Then there's a media. Media is how is this data going to get sent between two devices? It's going to be a hard cable. It's going to be the airwaves. So it could be anything of that nature. The physical media could be different types. It could be Ethernet. Could be copper cable, coax. So you got end-to-end devices. You got the media in there, and then you got services. What features, what am I going to do with this physical connection? Am I going to check my email? Am I going to check the internet? Am I going to do file saving? But those are the major components that, as a network designer, need to think about. Now, some of the components, end devices. End devices is where the message originates or ends. And then data will start from PC1 and then move itself all the way back to somewhere else in a totally different area. So the data originates at one end, flows through the network, and arrives at the other end. So you got end devices, two different ends. Now, there are several intermediate devices. So when you look at this picture, I've got end devices here, and then all of a sudden I got a device here, here, that are in between a set of end devices. These are intermediary devices. They are devices that connect networks together. So they can be switches, wireless access point, wireless, routers, firewalls. So each of the data that flows through there says, how do I regenerate the signal between these? So I have to keep the pathways up. How do I notify devices when there's errors or communication failures? All of these intermediary devices are talking to each other. Now, Got the so I got all these end devices, intermediary devices, but now I got to connect them all together via some kind of media. There's three major types of media. You got copper, Ethernet, you got fiber optics, and you got wireless. Those end up being the three major things. Each one has its own pros and cons as far as ease of installation, cost of installation, speed of data that can go across them. But as you're designing your network, you've got to decide which that's going to be. Now, when you're designing a network and when you get into the tool we're going to use in this class is Packet Tracer, you're going to have what they call network representation or network graphics diagrams for little different devices. So you got end devices, intermediary devices, and then some kind of media. So you're just going to have to make sure you understand, as the assignment is asking you to build a network with two computers and a router, what do I pick, this box or this box as an intermediary or not? So it's understanding the roles and functions of each of the intermediary devices, how I'm going to connect to my end devices. And then, of course, which media am I going to use to connect everything together? Now, when I'm building a network, there are two different diagrams or topologies, layouts of a network. There's either a physical topology, which is, okay, these are the actual physical location. It's on this floor, this rack, this shelf. Or the logical topology, which says, how is the data going to flow through my network? How's it going to go from this laptop over to my email server? How's the data going to flow? I may not necessarily care which route they take, but yet I want to understand the logical, how's the data going to flow through my physical design? I'm going to build a physical design, and then I'm going to logically decide who can talk to each other and how. Now, there's a couple of different types of network. The two most common are local area network and a wide area network. And basically the biggest thing here is geography. The local area network handles a small, confined, usually a building and maybe an office complex. Wide area network says I'm going to have a wider coverage, larger geographic term, and maybe I have to involve a telecommunications company service provider to allow my connection. So in this case, I may have this central office as my local area network, but I'm going to use a wide area network to handle this central office back to the home office. But I will pay an AT&T or Sprint or somebody to handle that communication, the media between and the intermediary devices between those two networks. And that would consider, since I'm covering got a telecommunication service provider involved and a larger geographic, and I've got a wide area network. Now there's three other smaller devices. One, you got a metropolitan network, and that pretty much says I'm covering like the city of Lenore. Boom. I'm going to put a network together that has anybody can talk to anybody in Lenore with that environment. My wireless local area network, which pretty much a lot of us have at home, or a storage area network, where how am I going to just store the data and move it between point A and point B. Now, local area networks. There's a couple of different characteristics of a local area network. One, it handles a small geographic area. It's usually administered by a single organization or person. Most of it's ourselves at home. And it provides a high bandwidth to end and intermediary devices. Now, wide area networks, they interconnect local area networks over wide geographic between cities, states, countries. Usually administered by multiple service providers. And typically, the wide area network is slower. So this link between those two networks is usually slower than the data that's on this network here. So just keep that in mind. Now the internet. The internet is a worldwide collection of interconnected local area networks and wide area networks. The local area networks are connected via a wide area network. The wide area connector are connected to each other by copper, fiber, cables, wireless transmissions, but not owned by any one particular group. And there's several international organizations that kind of help maintain this structure, and these are just a few listed here that you'll get into later. Now, there are some things called intranet and an extranet. Intranet is, I'm going to only have communication between people inside my company only. The extranet says, hey, not only am I going to get interfaces with my company, but I'll talk to customers, subscribers, collaborators, or then the internet, I'm interfacing the entire world. So you've got 3 different layers, types of networks that as a company you need to decide which one of those you're going to implement. Now, how do I access these internet connections? There's several different ways of doing this. You can have a DSL, wireless LANs, broad cable, mobile services. Sometimes you want higher speeds, you can get IP phones, video conferencing, data center storage. Some of the business classes are done with service providers, leased lines, Metro Ethernet. So there's different ways of connecting it. But for a small home office connection, they're basically 5. And actually, the dial-up is probably the least expensive, but it's also the one that's least used. Satellite helps for some of the rural areas that allow me to communicate out to some far-out providers. Sometimes you'll use the cellular. So how many of us have a cellular network? You're on the road and you're looking at your iPad, but you're using not a local area network, but or a Wi-Fi network. You're using a cellular network to communicate that way. Now there's a couple of different types. So you got DSL, which is pretty much runs over a telephone line. Usually have slower speeds, but costs are a little bit less. Or cable. Offers a higher speed, higher bandwidth, because now I'm pushing what? Because I'm pushing cable television through it, I get higher bandwidth, higher speeds, so more than likely I can get a higher data transfer rate. Now, from a business standpoint, if I'm connecting businesses together, there are a couple of different ways of doing it. I can dedicate a lease line. That means I'm paying everything to lease a line from point A to point B. I can fully lease the entire line or a partial of the line. I can create an Ethernet wide area network, which just kind of extends the local area network access to a wide area network. You're seeing more and more of that as time goes on. You can have business DSL or you can have satellite. Now, we're going to be using Packet Tracer to emulate what happens with live equipment. So it'll give you a lot of different what ifs and stuff. You'll solve questions. You may get tired of Packet Tracer by the time the semester's over, but maybe we'll have to find a time if there's enough people that want to do a hands-on lab with later in the semester. We can schedule a time to do that. So Packet Tracer allows you to explore things. It'll help you master any skill sets that you want to look for. But then let's look at the network as a platform. What do I mean by a platform? Well, there's a couple of different types of networks out there. You've got computer networks, you've got telephone networks, and you've got your broadcasts, your television commercials. And 30 years ago, you probably had three different lines that came in. You had 3 different vendors, rules of agreement, and with each one, guess what? Those things are changing. They're all converged. All these networks are communicating. My same 3 services are still there, but now I've probably got the one provider providing everything. Some of you probably have, let's say, a Spectrum bundled package, which gives you data, voice, and video. So that's what converged network is. All this stuff is starting to come together under one company's head point. And you got researching of that. Now the question is, when I'm building a network, what do I have to keep in mind? There's probably 4 major things you need to worry about. I need to make sure I can handle what happens when something fails, fault tolerance. I need to make sure I can grow as my customer base grows. Scalability. Got to worry about security. And then you got quality of service. What am I going to do? What speed am I going to do? So, just one of those things we worry about. Fault tolerance. What I'm trying to do is I'm trying to put in redundant devices to allow me redundant paths so that I got multiple paths. So if one device fails, the system can automatically route to a different one. Right now, if your home wireless router goes out, do you have any choices? And the answer is no, you don't. It goes out, you got to go buy a new one, get it repaired. You lost your whole network. Whereas if I'm building a redundant network, I'd have multiple paths. I would have 2 different ways of supporting this. So that's what we're talking about when we talk about fault tolerances. Scalability says, I want to make sure I've designed it so that I can expand quickly. So I'm not boxing myself in either my physical layout or my logical layout, that I'm boxing in future expansion to the system. Quality of service, I want to give voice and video a higher expectation because of, we've all had, when digital first came out, you remember your TV would get all those little itty squares in it when the signal was too slow. We didn't like it, but that's quality service. Now I want to give a higher priority to certain data. Where voice, I'm not as concerned. My brain can kind of pick up what's not happening, what I'm not hearing, and fills in the gaps where I can't do it on a live video. So quality of service is just kind of mechanisms to decide who's going to get what priority of this physical equipment to allow you the best quality of service for that feature. And then, of course, security. There's a couple of different types that must be addressed. There's network infrastructure security and there's information security. So the network infrastructure, I want to make sure I've, physical security of the network devices, prevent unauthorized access. On the information, I want to make sure that only the right people get access to it. Now, there's 3 goals of this. I want to make sure that it's confidential. Only the people that intended get it. The integrity, I want to make sure that what I'm sending is what's getting received. And that it's available, that I'm expecting that when I'm going online, that service is available when I want it. So now let's look at where the future of network is going. Now, some of the new trends, it's been changing. Bring your own devices. Yes, a lot of companies say, hey, I'm not going to provide you equipment. You buy your own, whatever you want, and hook it into my network. Online collaboration, video communication, cloud computing. All of these are things that are coming into trend. Bring your own device says, hey, bring my own laptop, netbook, tablets, phones, smartphones, e-readers. You bring them into the company, I'll work them into the system. Online collaboration just allows you to have multiple customers work together, whether it's Cisco WebEx or any other of the tools out there. It just allows multiple people to get in a video conference, modify data, share data on ongoing places, and go on. Video conferencing. Now, Cisco's telepresence. I can talk to anywhere, anytime. So it's just not a bad thing. And then, of course, cloud computing. It's such a big deal that it allows me to store my backup. Google Drive. What have you been doing? I'm storing all my data someplace else. So I'm putting my stuff out on the cloud, some external data center that's supporting this. And so it can be running applications remotely, could be storing data remotely. So a lot of different aspects. A couple of different types of clouds. You got public clouds, which says, hey, pay as you go. Then there's private clouds that say, hey, I'm only going to let certain people in here. So usually, such as the government only allows you access to certain things. And then, of course, you got hybrid clouds, which can be made up of 2 or more clouds, part public, part private, just kind of mix and match. And then you got some custom mades. And it says, hey, I'm making my own type of cloud. I want to build it and provide it what I want to do. Smart homes technology. Also, now you're getting what? Cars driving on a regular basis, driverless vehicles. So those are things, of course, now you're getting what kind of smart things. I can set the heat, the lights, find out if my refrigerator's low on milk. All of that stuff is important. There are some devices out there that will actually allow me to use the power line in your house to give you another access point so that you can expand the service in your building to help. Wireless broadband, whether it's DSL cable, just another wireless. You get a wireless internet service provider that you can run all your services on. I don't use this as much at home as I do in your car or in my cell phone. So it varies. So just depends on what kind you're doing. Of course, now there are definitely network security issues. Security is definitely a big thing in this chapter. This semester we'll cover a lot about security. It can be implemented in the environment to secure the data. We may have it put in firewalls to block people come in. I got to make sure that I can handle both internal and external threats. So those are issues. External threats, viruses, Trojan horses, spywares, hacker attacks. Internal attack, those bring your own data devices in. Am I bringing in a virus? Am I bringing in some of these external attacks as I attach my devices into this network? Maybe I don't intentionally cause a problem, but I can leave my password unattended, give it to somebody unnecessarily, don't expect. But how do I prevent it? I prevent it with multiple layers of security. I've got network security, either antivirus or firewall. So now there's a couple of different things you want to worry about with security also. Dedicated firewalls, access control lists, access controls. They're actually allowing, now we can actually say down to a part of a message or a type of service that's being sent, whether I will forward this information on or not. So it's allowing me to control what packets flow through my network. Then you can have an intrusion prevention advice. So that's, it just kind of says, hey, if something comes in, it doesn't make sense, I can break it, I can kill it. Or I can have a virtual private network. So I can set a one-to-one network between the two that only requires a special password that's got its own little environment. Now, the Cisco network environment, basically it's spent a lot of years and very successful in putting the people and services and devices together to build this out. So Cisco's got a wide range of products and switches and routers to do this. And if you're going to stay in the network industries, as with a lot of the technical fields, you're finding certifications, and employers want certifications to help know that you know the environment. So this class, you're taking the NET125 class, is the first of two we offer to prepare for this first exam. So NET125, 126 prepare you for the CCE&TI, or the Cisco Certified Entry Network Technician. And then our 225 and 226 now takes you up a level to this associates, the Cisco, Cisco Certified Network Associate, so the CCNA. So those end up being two of these that if you wanted to, you could get, at least have the material presented in such a way that you would be prepared to sit for one of those exams. And then, of course, there are several jobs out there that, and I think actually I probably had you assign this one, but we'll look at Moodle as far as how that's all worked out. So hopefully that gives you everything you need to understand where we're going. It's kind of a quick, easy, nice video kind of that you want to take a look at on how it works. It's kind of a cute little video. And then, of course, we got to make sure that we know that networks impact our lives. Connecting two devices together via a whole lot of different types of media. And networks got to make sure they're fault tolerant, scalable, support quality of service, and they're secure. So hopefully we've explained a little bit on how networks are used, different devices and topologies, some basic characteristics, and then some trends of the future. So hopefully that has helped you. And if you have any questions with this lecture, please let me know. Thank you.